Hello and welcome to this presentation on Iseg high voltage power supply modules. In this video we will take a close look at the voltage measurement accuracy and linearity. We will see how you can make sure that an Iseg high voltage module matches your requirements in terms of voltage measurement. Depending on your application, this might be very important. If you use Iseg modules to power detectors, for example, the detector gain strongly depends on the supply voltage. Therefore, a precise knowledge of the applied voltage is fundamental. This gets critical if a single high voltage module must supply a wide range of voltages for different kind of detectors. In this case, the power supply will operate at the extremes of its nominal voltage range. Iseg high voltage modules are guaranteed to have a very high voltage measurement accuracy. This accuracy is guaranteed in the range from 1% to 100% of the nominal voltage. As a consequence, all Iseg modules can cover a very broad range of applications. In this presentation we will show the importance of the Iseg specifications and calibration report. We will also go through the process of evaluating the accuracy of the voltage measurement by ourselves. This is a process that can easily be reproduced if you have the slightest doubt about your own hardware. We will also use the fine adjust option. This option guarantees that the set voltage and the measured voltage correspond. This option requires some extra time for the output voltage to stabilize. Therefore, it might not be appropriate for all applications. This is our measurement setup. We are working with an M-Pod crate with M-Pod C controller. The high voltage module is a 16-channel 1 kV EHS high precision module. Channel 2 is connected to a Keithley 2002 multimeter for voltage measurements. Easy LVHV will be used to control the hardware. Please check the datasheet of your Iseg module to find out the details about measurement accuracy. For standard precision modules, the maximum error is defined as plus minus 0.01% of V out plus 0.02% of V nominal. For high precision modules, the maximum error is defined as plus minus 0.01% of V out plus 0.0% of V nominal. This precision is guaranteed for the range from 1% to 100% of the nominal voltage. Now we will check if the Iseg module respects these specifications. From the connection page we connect to the M-Pod crate over SNMP. We select channel 2 of the EHS module by a double click. Now we set the output voltage to 1 volt and switch the channel on. The set voltage and the voltage measured by the Keithley and the high voltage module are written to an Excel spreadsheet to compare them later. In several steps we increase the voltage until the nominal voltage of 1 kV is reached. These steps are smaller at the extremes. The data collected during these measurements has been written to an Excel spreadsheet. The first column holds the set voltage. The second column contains the values read from the voltmeter. The third column holds the values measured by the module and read from the control software. We compare the Keithley and Iseg voltage measurements in the fourth column. We can see that these values are well below the tolerance given by the datasheet specifications. This is also true for the values below 10 volts. These values are well below the 1% range defined in the datasheet. We have fitted a linear approximation to the measured values. The parameters have been computed to match these values as much as possible. We can see that the gradient of the function is 1. Only the offset part is relevant. The error of this linear approximation has been computed in the Excel spreadsheet also. This error expresses how well all measured values lie on a straight line. It also gives an estimation of the accuracy of relative voltage measurements. We can see that the error is within a 10 mV range. Now we will take a look at the fine adjust option. The fine adjust option activates an additional regulation loop that makes sure that the measured voltage corresponds to the set voltage. This additional regulation is slow, especially at higher voltages. This is the reason why the option is not active by default. This option is guaranteed to work in the range of 1% to 100% of the nominal voltage. The option can be activated from the Create menu. The software signals that the corresponding channel flag has been set. Now we change Vset to 900 volts. After ramping up, we realize that the measured voltage is above 900 volts. After some time, the fine adjust regulation loop locks in and reduces the voltage to exactly 900 volts. A much faster way to check the accuracy of your Iseg module is to take a look at the calibration report. This report is delivered with every purchased module. In general, the error measured after calibration is well below the maximum error given in the datasheet specification. However, this is subject to variations of the production process and the used components. Therefore, it is impossible to guarantee typical values for measurement accuracy. This is the calibration report for the module used in the previous measurements. The module has been calibrated 5 years ago. Still, the error we measured for channel 2 corresponds precisely to the error given here. We have seen from our experiments that Iseg modules respect the maximum error given in the datasheet and the value from the calibration report. When operating in a range of 1% to 100% of the nominal voltage, the measurement accuracy is high. This allows to use most Iseg modules even for applications where low voltages are required. This precision is reached mainly due to the Iseg resonance switching technology, but it also requires high-quality components and assembly process. When you try to find a high-voltage module for your experiment, verify that the constructor specification match your requirements. Check that the power supply will be operated within the safe voltage range. Check that the measurement linearity is sufficiently high. Check that the maximum measurement error respects your specifications. When you are in doubt about your hardware, don't hesitate to measure by yourself. Use a well-calibrated voltmeter. You can also make sure everything works well, for example at higher temperatures or with a load on all channels. The fine adjust option can be used to make sure that Vset is accurately reached. However, as the additional regulation is slow, it might not be recommended for every application. After several years of use, a recalibration of your hardware might make sense. If you have hard or software related questions, don't hesitate to contact us. Contact Iseg for questions related to high voltage modules, contact Weiner for low voltage modules and import crates, contact Physical Instruments if you are based in France, and Analog Flavor if you have questions related to the use of the control software EasyLVHV.